Okay, let's go ahead and take a look at the monitoring progress for 5.3, our geometric sequences. Remember, the way to use this video is to fast forward to check your answers on your monitoring progress. If you get any wrong, go ahead and rewind to get the full explanation for that particular problem. Okay, let's take a look at number 1 here. We're determining if the sequence is geometric or not, and if it is, we're to find the common ratio. So on this first one, if I do 3 divided by 0, that gives me an undefined term, so I can't really use that one. If I do 8 divided by 3, I get just a little bit over 2. If I do 15 divided by 8, I get just a little bit under 2. So that ratio is not the same, so I can say, no, that is not a geometric sequence, and therefore we don't have a common ratio. On the next one, I'm taking a look and I see 3 and 12. 12 divided by 3 gives me 4. 48 divided by 12 gives me 4. And 192 divided by 48 gives me 4. So my ratio is 4. And yes, this is a geometric sequence. Now looking at 3, we have negative 24 divided by 4. So I get negative 6. 144 divided by negative 24 is equal to negative 6, and so on. So yes, this is a geometric sequence, and my ratio is equal to negative 6. Let's now take a look at our next one, which is the recursive formula. Remember, our recursive formula is a to the n equals a to the n minus 1 times r. So for this first one, I've got to figure out what r is, and that's going to be negative 6 divided by 1, or negative 6. 36 divided by negative 6 also gives me negative 6, as does negative 216 divided by 36. So now I have a to the n equals a to the n minus 1 times negative 6. Let's look at number 5. 8 divided by 4 is 2. 16 divided by 8 is 2. 32 divided by 16 is 2. So my ratio is 2. So I have a to the n equals a to the n minus 1 times 2. Now let's look at the explicit formula. Remember, my explicit formula is a little bit different. That explicit formula that I've got is equal to a to the n equals a1 times r to the n minus 1. So let's go ahead and take a look at number 6. So in number 6, I have 18 divided by 3 gives me 6. 108 divided by 18 also gives me 6. So my r is equal to 6. My first term, a1, is 3. So let's go ahead and write our equation. A to the n equals 3 times 6 to the n minus 1. Now let's look at number 7. Number 7, we have negative 8 divided by negative 2, so that gives us 4 for our ratio. And if I check 32 and 8 and 128 and 32, I get the same thing. My first term, a1, is negative 2, so my equation is a to the n equals negative 2 times 4 to the n minus 1. Now we're going to get into a word problem here. Population of brown bears is around 110,000. That's going to be my A1, 110,000. When I take a look and see that to help keep the population in check, they're decreasing at a rate of 2% each year. So that means my ratio is going to be 1 minus 0.02 or 0.98. How many will there be approximately in 75 years? Using find an explicit formula. Okay, so my explicit formula to use this would be a to the n equals 110,000 times r, 0.98, to the n minus 1. In this particular case, I know that we're looking at 75 years. So I want to find the a of 75 years. So it's going to be 110,000 times 0.98 to the 74. So I'm going to go ahead and grab my calculator, and I'll give you a moment to go ahead and check yours. 0.98 to the 74th power times 110,000 is going to give us a value of 24,668 bears. Remember, we can't have a fraction of a bear. Okay, we'll see you next in Geometric Series.